So have your attention up here. This is number 2 on the review packet for the Benchmark 5 or Chapter 4 test. It's actually a problem out of your textbook. It's number 20 on page 215. Here's the problem. Jane is 2 miles offshore in a boat, wishes to reach a coastal village 6 miles down a straight shoreline from the point nearest the boat. She can row 2 miles per hour and can walk 5 miles per hour. Where should she land her boat to reach the village in the least amount of time? So she wants to get from this point in her boat to this village as quick as she can. So she could row at 2 miles an hour straight to that village. Or she could row straight to the shore at 2 miles per hour and then walk along the shoreline at 5 miles per hour. Or maybe she decides that there's some other point in between that would allow her to row to that point and then walk along the shore and get there faster. So what we're trying to figure out is what's her best route so she can minimize the amount of time to get from this point to the village. All right? And it tells us that this distance right here is 6 miles. The village is 6 miles down the shoreline. It also tells you that she's 2 miles offshore. Her boat is 2 miles offshore right now. We're going to call this distance D, this diagonal distance. And we're trying to determine where she should aim her boat at. So let's call this distance right here X. So if that's X, and the total distance is 6, what would this distance right here be called? 6 minus X, correct. Now another formula you may know is distance equals rate times time. But really what we want to minimize is her time. We don't want to know distance, we want to know time. So if I divide by rate on both sides, what would time equal? Distance over rate. So to get time, we're going to take distance divided by rate. And we want an equation for her total time here. So let's talk about her total time rowing first in the boat. What divided by what would give you her time rowing? What's her distance? D. D is her distance that she's going to row. Okay? How fast can she row? 2 miles per hour. So D divided by 2 would tell you how much time it's going to take her to row the boat to shore. Plus, let's add on her time walking along the beach, along the shore. Well, her distance along the shore is 6 minus X that she's going to walk. How fast can she walk? 5 miles per hour, right. Let me make sure I'm clear on what I'm saying. She's going to row here, then walk here. So she'll never actually walk this distance of X here. But X is what we're trying to find. She wants to know how far down the shore should she aim her boat so that she can get to this village as fast as possible in the shortest amount of time. Now let's try to come up with an expression for D, because notice we have really 3 variables here. We have time, we have D, and we have X. So let's try to get everything on the right side of the equation in terms of X. So using this triangle right here, what formula could I use? Pythagorean theorem, yep. 2 squared plus X squared would equal D squared. So D squared equals 2 squared, which is 4, plus X squared. So D is going to equal the square root of 4 plus X squared. I'm going to substitute that in right there. Let's use T for total time. So it's going to be the square root 4 plus X squared over 2 plus 6 minus X over 5. So part A is our diagram. I guess any questions about the diagram before I go any further? Part B asks you to write an expression for the total time to walk and row to the village. This is the answer to B. That's our total time. Part C is to find that minimum time and where she should aim her boat graphically. So we're going to use our graphing calculator. We're going to go to y equals we're going to type in the expression. Now, keep in mind here that instead of t, I'm going to have a y. So my y coordinate will represent total time. So I'm going to go square root of 4 plus x squared. Close your parenthesis. Divide by 2. Plus parenthesis 6 minus x. Parenthesis divided by 5. Now, if we just take graph, there's a good chance we won't get the correct window. Let's think about what your domain is for x. Here's x in our diagram. What's the biggest x could possibly be? 6 miles, right. She could row straight to shore, walk the entire 6 miles here. What's the smallest x could be? 0, yeah. If she went straight to shore, actually, if she went straight to shore, x would be 6. If she rowed all the way to the village, then x would be, if she went straight to shore, x would be 0. If she rowed all the way to the village, x would be 6. So x has to be between 0 and 6. So we're going to push window. X min at 0, x max at 6. X scale of 1. We want to set our minimum and maximum for the y values. Just hit zoom 0 now, zoom fit. And I don't really like to try to find the minimum when it's right at the bottom of the screen. So what I'm going to do is move my y min down a little bit so I have some space down here to work. So I'm going to go back to window. Y min's at 2.11. Let's put it at 0. Y min's now at 0. Hit graph. Minimum's going to happen here. So I push second trace. Number 3 is minimum. I'm going to get my dot a little bit to the left of the minimum, push enter, and then a little bit to the right, push enter, and then back at the minimum and push enter. Draw a little graph on our paper here. So what's x represent? What would be the label on the x? Miles. Yeah, it's how many miles down the shore she should aim her boat. Okay? So we're getting an x of 0.873. Let's round it to 0.873. Something like this. So 0.873 miles. So she should aim 0.873 miles down the shoreline from what she would if she went straight to shore. And if she does that, how long is it going to take her to get there? 2.117. How do we know the rate?
It's miles per hour.
It's in miles per hour, so it'd be hours. Yeah. So it's going to take her about 2.117 hours. That's the fastest she could possibly get to the village if she aims 0.873 miles down shore from straight in. Any questions about that? Part D says solve it analytically, so that's what I'm going to do right here. Now to solve it analytically, I have to do the derivative, because I know, what's the derivative going to be at the minimum right there? 0. It's got a slope of 0. So I know that the derivative is going to equal 0 at that one point. I don't see a slope of 0 anywhere else. So we're going to have to find the derivative. Now it might be helpful to rewrite this. Let's rewrite this time equation. Instead of dividing by 2, let's multiply by half. Instead of a square root, let's call that 4 plus x squared to the half. Plus, instead of dividing by 5, let's multiply by 1/5. So 6 times 1/5 would be 6/5. And minus 1/5 times x would be minus 1/5 x. That's also an expression you could have graphed. That expression is equivalent to the one you already graphed. But that expression is a lot easier to find the derivative of. Find the derivative, we'll call it t prime. So I'll take a half times a half, which is a fourth. Copy down your inside function of 4 plus x squared. Subtract 1 off your exponent, so that would make that negative half. Now you have to use the chain rule here. I have to multiply by the derivative of 4 plus x squared, which would be what? 2x, correct. What's the derivative of 6/5? 0. Good. What's the derivative of negative 1/5 x? Negative 1/5. Yep. We're going to set that equal to 0 because at a minimum, our slope or our derivative, this is our t versus x graph. Our slope is going to be, our t prime is going to be 0 at that minimum. We'll set it equal to 0. We'll solve it. Let's move some things around here a little bit. So we have the 2x on the top. Let's put the 4 plus x squared to the half on the bottom. And that'll make that a positive half here then. Let's add 1/5 to both sides to move the 5th over to the left side. Lots of ways to go about solving this. Any ideas? Can we cross multiply? Would that work or not?
Yeah.
You could. Okay. Could you multiply by 5 on both sides?
Yeah.
Yeah, we could do that. Let's do that. Let's multiply by 5 on both sides. Cancel that out. All right. What else might you want to multiply by on both sides? Right now I'm sitting with 1 equals 10x over 4 times 4 plus x squared to the half. How can I get this so it's not a fraction? What should I multiply by?
4.
4 and what else?
4 plus x squared.
That whole denominator. Yep, multiply by that whole denominator, which is 4 times 4 plus x squared to the half. That to both sides. Basically, it's the same thing you would get if you cross multiply. So the left side's going to come out to 4 times 4 plus x squared to the half. 1/2 power. What's the right side going to come out to? 10x. Yep. Still trying to solve this. What would I do next?
Divide by 4.
Divide by 4. So that would give you 4 plus x squared to the half equals 10x over 4.
Square.
Square both sides to get rid of the half. So that will leave you with 4 plus x squared equals, if you square the right side, that's going to be 100x squared over 16. We're getting there. Let me erase some of this so we have some room to write. Let's bring this up here. This is part D continued. So you have 4 plus x squared equals 100x squared over 16. That's the same as 100/16 times x squared. Let's subtract x squared off both sides. So I'm subtracting 1x squared off both sides. Gives me a 4 over here. 1 is the same as 16/16. So what's 100/16 minus 16/16? 84/16. You get 84/16 times x squared. What'd you do now?
So 16 over 8.
Yep, multiply the reciprocal. 16 over 84.
Oh my God.
X squared equals 16 times 4 is 64, so you get 64 over 84. What's the last step? Square root. Take the square root on both sides. So x is going to equal the square root of 64/84, which I hope comes out to 0.873. Someone do that and check for me. Question?
Why is it 84 over 60? Why did you go from 100 to 84?
When I subtracted 1 here, good question. When I subtracted 1x squared, I was thinking of that as 16/16. So 100 minus 16 is 84.
Okay.
Okay?
Good story.
That's the right answer. Okay. Comes out to 0.873 miles. And then if I wanted to find, if I knew my 0.873, but let's say I didn't know the time, how could I figure out the time? Plug 0.873 back into your original equation which I erased, but the original time equation. All right. Any questions about that one?
Can we use the graphing method on the test? Or are we gonna have to do it